These are the solutions to the questions at the end of lesson 1.4. Now, number 1. We've got a positively charged particle released in a uniform field. Now, it will accelerate and it won't stop accelerating because there's no other force acting to make it stop. So it will experience a constant acceleration and move in the direction of the electric field. So that's C. Now, number 2, if we've got two oppositely charged parallel plates, the strength of the field, and we're assuming that they're quite wide plates near each other, then we count the field as being constant between the plates except at the edges. So that's D. Now, question 3, we've got electric field. We know that the electric field is 1 over 4 pi E naught Q over R squared. So we're saying that electric field is proportional to Q. So if we're doubling Q, then that means we are doubling the electric field. And so that is D. And then question 4, what is the magnitude of the field due to this point charge? So let's write that equation again. Q over R squared. So it is 1 over 4 pi E naught times 6 by 10 to the minus 9 over 0.025 squared. So when we plug those into the calculator, we simply get it is 8.6 by 10 to the 4 newtons per coulomb, which is A. Now, question 5. We've got a very small ball that has a mass and a charge. We will need an electric field directed upwards to balance the weight of the ball. So if we show it, we've got the force from the electric field balancing the force of gravity. Now, the force due to the electric field is just E times Q. Force due to gravity is M times G. So we need for them to be balanced that EQ equals mg. So the electric field must be mg over q, which is 5 by 10 to the minus 3 times 9.8 over 4 by 10 to the minus 6. And that will be 1.2 by 10 to the 4 newtons per coulomb. Now in question 6, we have a large sheet of charge, and we know that the electric field for a sheet of charge is sigma over 2E naught, where sigma is the surface charge density. So we need to find what that surface charge density is. We multiply both sides by 2E naught, and we have E. So that turns out to be 2 times 8.854 by 10 to the minus 12 times 5 by 10 to the 6 newtons per coulomb, and that turns out to be 8.84 by 10 to the minus 5 coulombs per square metre. And question 7, so we have a square and the sides are 3.2 millimetres. So if that is 3.2 by 10 to the minus 3 metres, the area is that squared. So 3.2 by 10 to the minus 3 square metres. So we have an electric field and there's an angle. So we know that the flux, the electric flux, will be the electric field strength dot A, and so that is the magnitude of the electric field times the magnitude of the area times cos of the angle between them. So that is 1800 times 3.2 by 10 to the minus 3 squared times cos of 35, and so that turns out to be 1.5 by 10 to the minus 2 newtons meters squared per coulomb.